All right. So welcome to our fourth IVSS webinar. This one is on cleaning globe data for student research and data analysis. And I'll introduce our featured speaker in just a moment, but please feel free to type questions in the chat as we go. And I will post this meeting recording on the IVSS webpage likely later today, by tomorrow at the latest. So we'll have that there, and also on the IVSS playlist on YouTube. And next slide, please. All right, so for those of you who aren't familiar with the IVSS, I'm going to just give a really brief overview, and then I'll hand it over to our guest speaker. But this year, the 2025 IVSS, the theme is 30 Years of Globe, Understanding the Past, Present, and Future. And the IVSS provides an opportunity for students to share their Globe research with STEM professionals and the Globe community, and also get valuable feedback on their work from judges who volunteer their time to score and provide feedback on student projects. And the IVSS is open to students from all Globe regions and grades primary through undergraduate. Next slide, please. And in order to be considered for the judging process, IVSS projects should include an abstract or summary, a written research report, the criteria for which are on our website, and I'll share that in just a moment, an explanation for badges that students would like to earn, and a presentation that showcases the results of student research, along with any photo releases for students' images who are appearing in the presentation or project. Next slide. And this year, we're really excited to celebrate Globe's 30th anniversary in 2025. So along with the 30 Years of Globe campaign, which is encouraging the community and students to compare Globe data from the vast database. We've got over 250 million observations and measurements in our Globe database. So we're encouraging the community and students to access this data as part of their projects this year. So students can compare past Globe data to newly collected data if students are collecting new data, or they can use the data as a standalone to answer their research questions. And the data that students access can be from any time period, region, or any length of time. So we encourage you to tap into the Globe database. Hopefully this webinar today will provide you with some ideas of how to do that, and also submit your data to the Globe database. So I've got the link for the 30 Years of Globe campaign here, and I encourage people to check that out for more information. Next slide. And along with that, so to celebrate the vast amount of Globe data contributed by the community over the past 30 years, the highlighted badge for this year's theme is the Data Scientist badge. And so to earn the Data Scientist badge, students need to include an analysis of data downloaded from the Globe database, as well as their own data sources if they are collecting new data. And so we've got the detailed criteria for this badge on the IVSS badges page, which I'll share in a moment. And I do want to point out that to be entered into the stipend drawing this year, students must earn the I Am a Data Scientist badge. So the presentation today will hopefully give you some ideas of working with Globe data. And I think a couple more slides just for the timeline. The IVSS project window will open on December 5th. So students can start submitting their projects in a couple weeks. And the project window closes on March 5th. And then projects will be judged in the last 2 weeks of March. And we will provide feedback to students and celebrate all of our IVSS participants on Earth Day, which is Globe's birthday, on April 22nd. So we encourage you to tune in to some upcoming webinars for some more information about the IVSS badges. And then we've got one on ethical science and AI and how to submit an IVSS project. And on the next slide, I've got some info on how to learn more. So please visit our webpage to learn more about report requirements, information on various badges, resources, and more, including past recorded webinars that I have listed here. So if you scroll down to the bottom of the IVSS page, you'll see the recordings linked, including other webinars that help students and educators access data from the GLOBE database, and then a collection of videos from GLOBE partners and NASA scientists showing examples of GLOBE data and connections to other NASA Earth science missions. So with that, I'm going to turn it over to our guest presenter. We're very fortunate to have Tracy Ostrom joining us today to present on cleaning GLOBE data. Tracy is a GLOBE partner from the Mission Earth California project coordinator. She's a former high school science teacher, and she currently supports educators on the West Coast in implementing GLOBE in their classrooms, and has done a lot of work with data analysis and with classrooms. So thank you for joining us, Tracy, and I'll hand it over to you.
Thank you, Allison. Okay, so immediate disclaimer, I'm actually at an airport on the way to visiting one of our teachers with the Mission Earth program. And so if you hear a background saying, you know, all aboard, I'll apologize in advance if you hear that. So yeah, let's get started. Next slide, a little bit about myself. So the skinny of it is that I'm an educator at heart, even though I spent my first few years in the environmental industry. I was in environmental management after a stint in the Peace Corps, and started teaching right out of the Peace Corps, and taught, as Allison said, high school science, environmental science, and chemistry mostly in my tenure as a teacher. And after teaching, I retired in 2014 and started working for UC Berkeley and this project, a new project with NASA in science activation, and currently doing that work for the last 9 years with GLOBE Mission Earth. And along the way, and this is appropriate for our talk today. When COVID hit, we could no longer work with students outside collecting data. And so we really had to switch gears as to what do we do with our students and teachers. And that's when I did a presentation on looking at data, and it was GLOBE data to teachers online in a district, and really realized that they had absolutely no context of using data as a tool in the classroom. And so that really shifted my whole perspective of how data can support education, can support student learning. So I'm a PhD candidate at UC Davis in this area of data education with K-12 educators. So that's my trajectory, a little bit about myself. And next slide. We're really going to be talking about something called messy data. And I want to just kind of go through that quickly, along with this idea of what's data literacy versus data fluency. But really the heart of this presentation is giving you some examples on how students can clean up their primary data, their self-collected data, and how students can use the ADAT system and clean up GLOBE data. Brian, I'm glad you're here because we're going to be using tree height with that one. So yeah, so let's go ahead and get started and just talk real briefly about what messy data are. Often when we read and hear about messy data, it's data that's collected authentically. GLOBE has a perfect program for allowing our citizen scientists and learners to collect data, but sometimes it's not always in a format that we can use. And so the messiness kind of comes from kind of human error often, or technology instrument error. So it can really deter students like, oh, does this make sense? Or even researchers. So I'm really trying to turn that around and say, let's look at the messy data and use this as our tool for learning. And it made me think of the IVSS and this whole idea of doing a project on data itself. So next slide. So a little bit about data literacy versus data fluency real quickly. When I refer to data literacy, I'm really referring to a skills-based collecting data, organizing it, visualizing, etc. When I talk about data fluency, I'm talking about making sense of that data. And when we make sense of that data, we make sense of it in terms of problem solving or solution building. So those are the two definitions that I'll be using today in the presentation. All right, next slide. Cleaning data. So this is my big thing with cleaning data. We really want to engage our learners in really diving into this data and asking questions about the data. So we'll start out by asking what they notice about the data, and we'll do that with our examples today. And then we want them to interrogate the data. In other words, what questions do they have? What might be missing, or what are some inconsistencies of the data? Are the data that's been collected answering our research question, or is it going in a different direction? Is there anything unreliable? For example, if we read the metadata, we might read that the instrument wasn't working after 15 minutes or something like that. So these are kind of clues that we can use to understand and clean the data that we're working on. Okay, next slide. Here's our first example. This is primary data, and it's authentic data because it was collected by a group of students that I work with. And our objective in this primary data collection was to determine what data can be kept for analysis and what data are incomplete and need to be set aside before analysis. And so we're trying to answer our question of how weather might change throughout the day. Now, we collect a lot of data, but we're specifically trying to answer our question about weather data. Okay, so next slide. All right, so when we do this, we're going to look at accumulation of a table that has the data that's been collected and organized. So I give you the table already, but these are actually data literacy skills that the students will use in the collection and organization of data. And then as we go through it, we'll interrogate the data. In other words, analyze it. We'll clean the data and create a visual from that data. And then from that visual, we'll do a little bit more analysis and interpretation of the data to try to answer our question about how weather changes over time. So next slide. All right, I'm going to put in the chat this link. And I invite you, because this is really hard to see on a Zoom room. So in the chat is the link to data table 1. So data table 1 is the data table that we're using to do this primary data collection. As you can see in data table 1, once you get a chance to look at it, we have a bunch of columns of data. Each entry is a student group, the time they collected the data, temperature, the air temperature, humidity. We had a CO2 meter, so we collected CO2 readings. And then we did some surface temperatures too. So we needed to identify the surface type, whether or not our data were collected in the shade or the sun, and then what the actual reading of the surface temperature was. And we asked them to take 4 readings and create an average from that. So right off the bat, when you see that data, you might be asking yourself, there's a few things that are kind of weird about that. So can we go to the next slide? So when we go to the next slide, what we're going to do is inspect the data first. And this is a scaffolding approach. Maybe your students don't need to do this already, but for the group of students that I worked with on this particular exercise, we really needed to make sure they understood the data table. So we asked some questions about the data table. So we're asking how many attributes or variables, measurements were collected, what type of data were collected, and maybe some descriptions. We're not noticing anything first. We're just taking like an inventory, if you will, of what the table is telling us. And you can do that in small groups. You can show it up in the board. Let's go to the next slide, because the next slide is where we want to notice things. So here's what I'd like you to do is take a look at data table 1, and I want you to think about what you notice about the data in each one of the columns, starting with time, air temperature. I wrote some things down here that are in blue on the slide, but I really want you to take a look at the data table first and just get your own perspective of how you as a learner might notice portions of this data table. So I'm just going to take a 30-second pause here. Feel free to add your comments in the chat of your noticings. And then we'll move on. So you might notice right away that there are some blanks in this data table. Maybe the blanks come in under time, maybe they come under surface conditions, and maybe there's some metadata in there. I see something that says broken tool, a word that says foggy for surface type, and I don't know what surface type foggy means. So I noticed a few things about each one of these columns. And so even when they notice things, they can put together, wow, the range of the data is from here to here, or wow, this is missing, or all these data entries are between this and this, but something else is way out of whack there. So this really is best done as an educator modeling project where the students are getting together and they're starting to write down these noticings. And in a Zoom situation, I would do breakout rooms and small groups for folks to write down their noticings. So when we get to the point where we're actually noticing or taking note of this data table in terms of the type of data that are entered, we're going to go to the next slide, because what I want to do is I want to just sum up what all of these noticings are. So I'll summarize all these noticings. I'll get everybody's idea in the classroom as to what they said. These are just a summary of some folks, of some notes that the students made in the classroom I was in. And then we'll go to the next slide. And now what I want you to do is go back to table 1. And I want you to take a look at air temperature and time, just those two columns, air temperature and time. And I want you to try to narrow your noticings about just those two attributes. And are there any entries in there that you feel should not be included for analysis? Maybe something's missing, maybe something's incomplete. And what I'd like you to do is in the chat, write down the number of the entry that you feel should not be included in our data analysis, okay? So let's take about 30 seconds or so to do that. We're only looking at air temperature and time. All right, we got lots of great suggestions here. Perfect. So we noticed that there are some clear information that's missing or in error from these two columns about air temperature and time. And I think my information is pretty consistent with what's out there. But this is what I came up with in terms of the entries and why these entries maybe not so good. And it looks like a lot of folks are consistent with my thoughts as well. So what we're going to do is we're going to come to this idea of we're going to come with this idea of of cleaning the data. And again, this is our personal data. And we're going to create another data table. Only this time we're going to create a data table that just has the clean data. So go ahead and move to the next slide, and I'll put a link in the chat to this clean data table. Here we go. So now you can see we have a data table that's focused on our question. How do weather conditions change throughout the day? And we looked at air temperature as our indicator of weather. And we looked at time as to how time changed throughout the day. And we came up with what we're calling data table 2. And so you can see it's a little bit neater. We don't have anything missing right now. We're not sure if what the analysis of the data mean yet, but that's not the step we're at. We're just basically cleaning the data. So we get to this point where we're cleaning the data. And I'm just going to pause here and let you take a look at that. Anything stand out? Any questions about data table 2 that you're looking at right now? You can add it in the chat. Yes. So it was a liquid filled thermometer, Brian. And so they said, which line do we follow? And we realized that it had broken lines all the way up. So that thermometer was not the best for field use under its current condition. Okay, so here we are with our data table. We feel confident that we've excluded the data that were incomplete, and now we have a data table we can look at. And so we're going to go to the next slide, because what we're going to ask students is to put the data in Google Sheet and do just a scatter plot visual of the data. And so sometimes for our learners and for us, it's easier to analyze data in a visual than it is to analyze data in a table. So now we have our visualization of the clean data. And once we have this visualization, we can start asking our learners to kind of ask questions about the data. So if we could go to the next slide. And these are some questions that we would use in having our learners understand that visual that they're looking at. Looking at temperature data over time, a little bit about, kind of interrogating that visual so they understand what's on the y-axis and the x-axis, etc. Because, maybe your learners aren't at that point where they can just look at something. So if you need to scaffold, that sounds like a good plan to do that. Okay, so next slide. When we ask them to really dig deep, we're asking them to notice what they see about the new data in the visual. And so hopefully what they notice, and can you, Grace, can you go back to slide 15, please? So we actually can see the scatter plot. Okay. So when you see the scatter plot, you may notice that the data are clumped into 3 groups. That might be something you write down. You'll notice that the temperature of 30 degrees Celsius at 11:30 looks a little off or suspect, but the data are valid. So we're included that into our clean data table. We don't have any missing times out there. We don't have any missing data points. And so we want them to make these noticings of their visual so that they can start making some connections to their essential question and essential questions about temperature. So, okay, so we're going to go back to let's do slide 17 again. So this really takes us through this whole process of cleaning the data, analyzing, interrogating the data, making some noticings about the data. And this is all primary collected data. So now we're going to move on to our second example, and that's the globe ADAP system. So this is our objective. We're going to download data. This is, again, a part of the IVSS, is looking at globe data. So we're going to download some globe data from ADAT and determine what data attributes we need to answer our research question. And in this case, our research question is going to be, how tall are the trees in different areas of the US? So let's go to the next slide. So these are the filters that you're going to use in the ADAT system. The protocol is going to be tree height, and we're going to look at the tree height data from 2023. So from January 1st, 2023 to January 1st, 2024. And we want to make sure we have a manageable data count range, even though this is still quite large. And we're going to choose United States as our region to look at. And if we do that, if you add those filters, that filter information in, you're going to find that that's a lot of sites. So we have 2,460 sites. That doesn't include the data. That's just the sites, and these sites have up to 500 data counts in them. So that's a lot of data. So let's go to the next, and I'm going to put, when we download that, I'm going to put this in the chat, the first link in the chat. When we download that, we're going to get a very large data set. So if you could go to that data set on your own right now. This is the downloaded data from the ADAT system. And just real quickly, how many data entries do we have that you can see, you guys? How many data entries in this messy data? Yeah, 5,601. Oh my gosh, how am I going to get my head around that? So here's what we want to do. So we're going to go to this, I'm going to switch over, Grace, if I can share now. Awesome, thank you. So we're going to switch over and take a look at this set of data. And we're going to ask ourselves, what information do we need in order to process the data, clean it up so we can use it? And so I'm going to go by column, and I'm going to ask myself, do I need to know the globe ID in order to answer my question? The answer is no. Do I need to know the school? No, I don't need to know the school. I don't need to know the site ID. And you can kind of see where I'm getting at here, is that I'm cleaning up this very large data sheet. I really don't care what the name of the site is. I'm really interested in tree height and the latitude and longitude of the tree. So I don't even need to know the latitude and longitude of the site. So this is like the school site or the data collection site, and it could have several trees in there. So I could keep the elevation. I could keep that if I want, if that's going to help me answer some questions. I don't really care about the date the data were collected because I already entered my date. So I'm going to go through this. Each one of these columns I'm going to go through, and I'm going to keep the column that's going to help me answer my question. So this here on tree height, column R, is definitely a column I want to keep. I'm not concerned about circumference, so I would not keep this particular column about circumference. But I see here, there's a lot of information here that I would not keep. But here's some pretty important information that I want to keep, and that is the latitude and longitude of my tree height. So I definitely want to keep folks. I want to keep this data for folks who are going to be analyzing this data for me. So long story short, I'm going to create a table that's going to be cleaned because I got rid of, and I haven't even had a chance to go through and look at the actual data measurements. But here's now the cleaned data table, which I want to show you. and it's a little bit more manageable now. I still have a lot of data entries, but as you can see, I decided to keep these three pieces of information: the tree height, the latitude and longitude of each tree. So this is our quote unquote clean data from the ADAT system. Not that the other data weren't useful, but they don't help me answer my research question. So once I have this data, I need to do something with it. And as you remember in our other example, we had a visual. So what I decided to do is to take this tree height data and enter it into CODAP. Now there's many different types of online, both free and fee-based online data management systems. Something we use often and our teachers use often is this idea of CODAP. And so here is some NASA Globe tree height data from 2023. And as you can see, the number of attributes is exactly what I picked, but I added a couple attributes, and that was looking at the region and just the overall size. So I set categories in CODAP as to what a small tree, a medium tree, or tall tree would look like, so I could categorize them. And I put them in CODAP, and now I can use the CODAP tool. And if you're familiar with CODAP, great. This is, if you're not familiar with CODAP, there's great tutorials on the website itself that you can use. And this is just one way you can manipulate the data. So I've got my three regions of the US here, and I see from these three regions how many, as you can see, there's a lot of data in here, but I've kind of grouped these data into, medium or small or tall, etc. And this is really going to help me look at the data and answer my question about the distribution of trees in the US. And it's a really awesome tool, and it kind of also gives you this looks like, wow, I'm missing some tree data in 2023 in certain regions in the US. So I'm not here to teach you how to use CODAP because I'm a beginner user myself, but I feel as though these kinds of tools can help us understand how to visualize the data as we move forward, especially large data sets that are in our Globe database. So let's go back to our PowerPoint presentation, and I think we're on slide 21, Grace. Great. So this is what I was mentioning before, that there's all sorts of online tools that you can use. I know the go-to is Google Sheets, which there's nothing wrong with that. That's fine. But there are several other tools that you might consider exploring to help your learners visualize and analyze their data. I'm not advocating for any of these. It's just one of those things. So, all right. So we explored the data with CODAP, and let's see. Let's go with just our chip 23, the next slide. So in conclusion, and I know you've heard me yak quite a bit here, but we really just want to explore data in order to answer our research questions. So we want to focus on the data that's going to help lead us to that endpoint in analyzing the data and being able to answer our research question. I would say another good tip is take a look at the data in the columns. If the data aren't going to help you answer that question, then you can set aside that data. Never get rid of your deleted columns, but you can hide them. And then when you're using the ADAT system, just be careful when you pick your date range. As I just said, for a 1 year selection of tree height, I had over 5,000 entries, 5,600 plus entries of data. So you might want to narrow that down even more. And if you are using these big data sets, you might want to consider using an online platform to help manage and visualize that data. So I think that's about it. So if you have any questions, this is my contact information. And I appreciate your time and let me yak at you today. at the airport. So thank you.
Excellent. Thank you so much, Tracy. That was a great example of scaffolding up to, downloading data from ADAT and cleaning it up. So I really appreciate that. Does anyone have any questions for Tracy?
Hey, it's Brian. More of a comment. Thank you, Tracy, for that. That was great because, as you know, with the Trees Around the Globe Student Research Campaign, we've been going on for about 6.5 years, and this is one of the issues that students and educators have is that there's so much data out there. So how do we do some distillation of it? And I think this is great because just between tree height, land cover, and greening as part of our campaign over that 6.5 years, there's over 215,000 points of data in the Globe database. And that's just like almost mind blowing. And then when we asked the students to, hey, go and take a look at the NASA satellite data, well, then you're talking about literally trillions of data points. But yeah, I won't talk anymore about that. But thank you so much for this. And we're definitely going to share this during our probably our January Trees Around the Globe Student Research Campaign webinar, because this is a topic, as I mentioned, that often comes up. And that's what Peter Nelson, Peter Falcon, and I try to do for the last couple of years is how do we distill that data? You have all this data. What online tools do we use? How do we make it easier to download, like from ADAT or Viz or whatever? So, but thank you for this. This is great.
Thanks, Brian.
And Tracy, I'm not sure if you saw Grace's question in the chat. Do you have any advice for bringing in other data sources to compare with Globe database data?
That's a great question. I think NOAA data and NASA data from the My NASA Data website are probably my go-to. But I also know that you can look at local weather data from your area, your city. And in this particular case, on this primary data that I showed you today, this is something the students did is they went back and they looked at weather data, their local weather data, and they compared their data to the local weather data, just the online weather data stuff. So Weather Underground, weather.com are a couple other resources that are usable in looking at atmosphere data.
Excellent. Thank you for that. And I have a question about CODAP. I really like how you organize the data into different categories. And I'm wondering what criteria you used for the medium, tall, extra tall tree classifications.
So, the tree height is technically 5 meters and above. So we just did something very simple, 5 to 10, 10 to 15, and over 15, just as just to keep it really simple in terms of how we categorize the data. We couldn't look at the data and say where do they all fall, kind of stuff. So that's what we ended up doing, and it turned out to be a pretty reasonable categorization of tree height.
Yeah, it's a great visual to complement that. All right, any more questions for Tracy? All right, well, thank you again, Tracy, for this amazing presentation. The video will be posted on the IVSS page and we'll share that around. I think this is a tremendous resource for our IVSS students and educators. So thank you again.
You're welcome. And my last hurrah is like, don't be afraid to do IVSS projects that are really data centric. Not just use data as kind of an adjunct, but really dive deep into that data piece, and making sense of data is just such an important skill for our learners in these projects. So that's my last hurrah on data.
Awesome. Thanks, Tracy. And thanks for everyone joining us today. We look forward to seeing what our students produce with their data. All right. Bye, everybody. Let's stop the recording.